Hello everyone. So the homework for tonight, we have page 61, 1 through 21 odd, and I will be doing a few sample problems from this section. And the sample problems I'll be doing are number 8, 12, 14, 18, and 20. So some of the even ones. So first let's start with number 8. Number 8 says make a mapping diagram for each relation. Okay? So let's start by making a mapping diagram. So mapping diagram, we start with D for domain, R for range, and we draw the rectangle for domain and the rectangle for range. Okay, so far so good. So now the question is what goes inside domain and what goes inside range. So let's take a look at the problem again. So we have a whole bunch of coordinates here. And what is a domain? So the domain, if we went over in class, if you remember, is basically whatever is the input. The input is always the domain here, okay? So in this coordinate system, what would be the input? Well, the input here would be the x value. So all the x value are the inputs. So we have 0, -1, -2, -3. These are the x values and they are the input. So that would be the domain here, okay? And then we will always be able to assign them from smallest to largest. So the smallest number is -3, then -2, -1, 0. Okay, so let's go back to our homework. So -3, -2, -1, and 0. That is our domain. And what is range? Remember, the range is basically the output. So what would the output here be? The output is our 0, -1, -8, and -27. Those are the outputs of the coordinate system. So once again, we put them in order from smallest to largest. So -27, -8, -1, 0. Okay. So the range here would be -27, -8, -1, and then 0. Okay. So now the question is, what goes where? So 0 goes to 0. So we have 0 here goes to 0. And then what's next? So the next, we have -1 goes to -1. Okay, so -1 here goes to -1 here. And then after that, we have -2, -8. That's the pair. So -2 goes to -8. And then finally, we have -3 goes to -27. Okay, so we have -3 here goes to -27. And that will be our answer for number 8. Okay, so let's go on to the next one. So the next question we have is number 12. Okay, so let's go to number 12 and see what the question says. Number 12. Determine whether each relation is a function. Okay, so what is a function again? Remember, a function is basically for every input, there's only one output. That's it, one. Every input only have one output. So let's check if this is right. One input, 1 goes to -2. Okay, is there any other ones? 1 here goes to 3. So notice here, 1 goes to -2, 1 goes to 3. So we have one input, in this case 1, goes to two outputs, -2 and 3. So we know number 12 is not a function because for every input, you do not get one output. Okay, so now let's go to number 14. Number 14, let's see what the question says. Number 14 again, determine whether each relation is a function. Okay, so we have these 4 pairs of coordinates. See if it's a function or not. 17 goes to 15 over 4. Okay, so we have an input 17 and it goes to an output 15 over 4. If it's a function, 17 can only go to 15 over 4. It cannot go to any other number. It cannot have any other number as an output besides 15 over 4. So let's see if it's right or not. Any other 17 inputs? Nope. So this works. How about 15 over 4? 15 over 4 goes to 17. So any 15 over 4 can only go to 17 because you can only have one output. And once again, this check out because there's no other 15 over 4. And 15 goes to 17 over 4, good, there's only one output. And then 17 over 4 goes to 15, only one output, perfect. So number 14 is a function because for every input, you only get one output. So let's see what else we have. So number 18, okay, let's try number 18 now. What is the question for number 18? Number 18, okay. So the question asks, use the vertical line test to determine whether each graph represents a function. Okay, so remember what the vertical line test tells us. So let's do some graphs here, okay? Vertical line test. So you have a coordinate system, and let's just draw a graph, okay? So the vertical line test tells you that for every input you have one output, that is a function. To see if this is a function or not, you draw a line, and it tells you at this point, at this x value, you should only get one y value. And let's see if that's right. You do, which is this point right here. And the vertical line test again. Let's draw another one just to see. So for this value x value input, you get one output, which is true. You only get this one y value. You don't get any other ones. And it seems like every single line that we seems to draw, every input goes to one output. Every input goes to one output. And this turned out to be true. You're right, this is. So what would not be true? Let's say I have another graph that goes like that. Now notice that for every input here, this x value, you have two outputs. So here, this would not have satisfied the vertical line test. Okay, so that's just a little review of the vertical line test. So now let's take a look at this question again. So let's look at this graph here. Okay, notice this graph. Let's draw an imaginary vertical line here. Notice that for every input, you only get one output. Every input, one output, because there's only one y value for every x value. So let's choose this x value here. Notice you only get one output. What about this x value here? You get one output. What about this x value here? You get one output, which is this y value. So it seems like every single vertical line that you draw, there's only one y value. So based on the vertical line test, this is in fact a function. And then number 20. Let's take a look at number 20 here. Good one. Okay, so you have this S-shaped looking graph. Okay, so let's draw that here. So it looks something like this, right? Something like that. Okay, so notice that let's pick a value here. Let's pick this x value. If you draw the vertical line, notice you have three y value. 2, 3. So for every input, this x, you get three different outputs. So based on the vertical line test, it failed. So it's not a function. Okay, so again, if I pick this x value, you have two y value. If I pick this x value, you have two y value. Now notice if I pick this x value, you get one y value, but it doesn't matter because here it passed the vertical line test, but the graph as a whole has parts of it which failed the vertical line test. So if the graph has any part that failed it, then the entire graph is not a function. Now if I happen to just cut up this little piece right here, this will pass. But because the graph has this S shape here, this part will not pass. So the whole graph will not be able to pass the vertical line test. So it's not a function. And that is basically some of the homework help we have for now. And if you have any questions, please ask me tomorrow in class, okay? Thank you.